Hi, Danny. Welcome to lesson number 66. Today's lesson is going to be super fun, okay? And we are going to start out with your 90 division facts. Wow, that is a lot. That's a lot of division facts, but you have 5 minutes to do it, and I know you can do it. So make sure that you have a pencil ready. If not, pause the video and go get it, and you have your math facts in front of you. And I am going to get my timer out. Okay, and I'll put on some nice relaxing music while you do this, okay? Not like that history video where the background music turned out to be the main music. Sorry. Anyway, here we go. On your mark, get set, go. You're doing awesome, Danny. Keep going. Good job, Danny. Keep going. That's about 3 minutes. You're doing great. Oh, sorry, Danny. I didn't stop it in time. I didn't mean to go past the time. Sorry. But that was about 5 minutes. Okay, good job, Danny. You probably finished all of that and you were like, when are you going to stop, Mom? Anyway, all right, here we go. Let's jump into the lesson, okay? Today's lesson is going to be super fun because we're going to talk about 2 new words. One is similar and one is congruent figures. So figures means shapes. So we're going to talk about when shapes are similar, kind of like this triangle and this triangle, and when they're exactly congruent, okay? So that's going to be the lesson for today. I think you're going to get it right away and it's going to be awesome, okay? But first, let's look at this cartoon. This triangle here is saying, why is the obtuse triangle always upset? Because it is never right. Oh, and look at the obtuse triangle. So it's obtuse because it has this, this big angle right here. And you know that an obtuse angle is greater than a right angle. A right angle is kind of like this triangle has, where it's perfectly 90 degrees or perpendicular. So this triangle looks like it's always right. This triangle is not going to be right either. This one's never right, but this one is definitely not right because this angle is super big and these angles are super small. So get it? It's never right. Okay, that's pretty funny. Let's go on to mental math. And mental math for this part, they're going to have you multiply numbers ending in 2 zeros. So things like 200, there's 2 zeros there. And you're going to multiply it by numbers ending in 1 0. So this is practicing basically adding zeros to your multiplication, okay? And I'm going to show you some beautiful ocean pictures while we do that. Okay, here we go. So the first one is 200 times 10. Okay, you probably already did that. So I'm just going to tell you that this one is 2,000. So check your own answer on that one, okay? Make sure you have enough zeros. Okay, the next question is 300 times 20. What is 300 times 20? Okay, write your answer. Can I tell you on this one too? Because that way you can check it and make sure you're getting these right. The answer for this one is 6 because 3 times 2 is 6. And then how many zeros? 3 zeros. And notice that there's 3 zeros altogether. You're doing great. What about this one? 400 times 50. I'm going to let you figure it out. This one's tricky, and so I'm going to give you the answer on this one too. The reason it's tricky is because when you do 4 times 5, you actually get the number 20. And then you add the 3 zeros, so your answer should be 20,000. Okay, so check yourself on that one too. All right, now I'm not going to give you the answers on these because these are just going to be a review for you. What is 250 times 10? Okay, what about E? $1 plus 29 cents. Okay, what about F? $4.47. Whoops. Plus $2.95. Write your answer. All right, we are going to move on to patterns. And I put this little GIF here because this guy is seeing patterns in his brain. Our brains can recognize patterns. So this is going to be, you're going to get this for sure. I'm going to move that out of the way though because it's kind of distracting. Okay. So it says at the beginning, counting by fives from 5, we say this sequence, okay? So we're going to look at this. We say 5, 10, 15, 20, 25, 30, and you're used to doing that. But what if we count by fives starting from the number 1? If we start with the number 1 and then we add 5 to each number, we're going to say 1, 6, 11. See how I'm adding 5? Each time I go to the next number, I'm adding 5. 16, 21, 26. All right, now their question to you. If you understand that, you'll be able to do it. What do we say if we count by 5s starting from the number 2? So we're going to start with 2. What's the next number going to be? And we're just going to add 5 every time, right? So it's going to be 7. What about the next number? Add 5. What's it going to be? 12. Okay, next one. And you figure out a few more of these, okay? Because I know you can do it. I'll let you pause it there, and when you're ready to come back, we're going to jump into the new concept. And the new concept is kind of fun because it's going to show similar and congruent triangles, kind of like these triangles here. They look like they're best buds, huh? Similar and congruent triangles. So they show us these 4 triangles. So look closely at these 4 triangles and notice which ones look similar and which ones look exactly the same. And we notice, let's compare these two first, that triangle A and triangle B actually have matching angles. So this angle kind of looks like this angle, and this angle kind of looks like this angle, and this angle looks like this angle. And it turns out that their angles are exactly the same. And I know that because what I did is I made this triangle and then I made it big to make triangle B. So they're actually exactly the same. Well, not exactly the same, because what's different about them? The thing that's different is this length. If you measure the length, like took out a ruler, it's not the same as this one. Triangle B has longer sides, even though the angles are the same. So they look similar, but they're not exactly the same. So that's our first vocabulary word. These are similar because their angles are similar, but they're not exactly the same. The way that you make triangle A look like triangle B, one way is if you enlarge it, like I just did by stretching it out. Or you could make it look like triangle B by using a magnifying glass, and that would make it bigger, and then it would look like triangle B. So, but because their sides are not the same length, they're not congruent. Now there are 2 triangles here that are congruent. And I'm going to move this triangle out of the way so you can see better. Triangle A and triangle C are exactly the same. And I know they're exactly the same because I just copied one and put it and made it side by side. See how I did that? Look how they're exactly the same. That means that their angles are the same, but also their lengths are the same. So these are not just similar, these are like identical twins. And when they're like identical twins, we call them congruent. And congruent means that they have the same size and they have the same shape. They're kind of like identical twins. Now, triangle D is the only one we haven't talked about, but this one doesn't look like, it doesn't look like any of the other ones. And in fact, even if we twist it, it still is not the same as the other ones. The angles are different and it's not the same at all. So this one is not similar and it's not congruent. So that one's just the outcast. B though, B is similar. It's similar, remember that word? But it's not congruent. Okay, so I think you got that, Danny. Let's go over an example. Which of these rectangles, now we're talking about rectangles, are similar? And here I gave you some twins from SpongeBob, right? And so these guys would be congruent because they look exactly the same. But they're pretty distracting, so I'm going to move them out of the way. Which of these rectangles are similar? Okay, so I'm looking closely at the rectangles and I want to know, well, which of them are exactly the same? And oh, in your lesson, this one is called A, this one's called B, this one's called C, and this one's called D. All right, so if you look closely at them, we want ones that are similar. So it wants to know which ones are similar. We're not going to pick two that are exactly the same. Whoops. Actually, I'll just get rid of that for a second. We're not going to pick two that are exactly the same. And the reason is because those would be congruent. Like I'm looking at this one and this one, and those are exactly the same. So that means they're not just similar, they're congruent. So I'm not going to call them similar. But which one looks like this, just bigger? And I think it's C. Because if I look at this length and this length, it kind of looks like the same proportions as this length and this length. But if I look at A, this length might be okay, but this one's way too long. It would have to stop like right there if it was similar. But I don't think A is similar to anything. But C looks similar to B and actually D. So I would say the ones that are similar are B, last one's B again, C, and D. Because they're the same shape, just one is bigger. Okay? Oh, and I guess you can call B and D similar because they are the same. So I guess you can be similar and congruent, because why not, huh? All right, now it wants to know which of these rectangles are congruent. So that's a little bit of a different question. They want to know which one is exactly the same. Now there's two little ones and two big ones. And I think if I did this picture right, that, this one right here is, oh no, now I changed it. Oh, poop. Okay, that's all right. I was going to try and show you that this one is actually, oh, there you go, exactly the same as B. Like if you put them together, they would overlap. And so B and D are congruent. The two big ones are not exactly the same. So like if you take this big one, see, it doesn't overlap at all. So they're not congruent. Okay, so here's some cute little patterns to look at, and we are all done with today's lesson, Danny. Good job for paying attention. Great job today. And I hope you enjoy your math, okay? I gave you some extra paper, so that way, because it's hard to write on these little papers that I give you. So use your extra paper to do the work, and then only write the answers on your paper, okay? Let's see if you can do that. All right, love you, Danny. Have a great day. Bye.